the last 30 years, I have been studying lean systems. I'm sure all of you have heard of production system. This was the contribution of Taichi Won of Toyota, Shigeo Shingo, Masaki Imai, and so many Japanese pioneers. So, sometime in 1985, when I got exposed to this first through some companies, I was really wondering, because I've been trained in mathematical models, how to develop the production plan and control the schedules and so on. But then when I read this concept, when I was exposed to this concept, I was really dumbfounded. Can something be so simple? So I started exploring, and at MIT, I attended a three-day training program that is in Cambridge, Massachusetts. And I read these books. These are 3 books among hundreds of books I read. These are the best. MIT has started the IMVP program, that is International Motor Vehicle Program, to truly find out the characteristics of lean, which was being taught by different names by different companies before. So they started writing down on the board, blackboard, the characteristics of lean, such as it needs less investment, it needs less floor space, it needs less inventories, it needs less number of people, and the concept to launch as product design phase, and the order to deliver, that is order processing system, and then problem to repair, that is service. Everything happens with less effort, few people, and then more efficient. So they have written down all these principles of lean, and then they thought, what should we name it? Because previously there were many names, confusing names, such as just-in-time, continuous flow manufacturing, material as needed, and so many names were there. Then they thought, because it needs less of everything, it must be called lean. That word lean took birth in MIT during the IMVP program, International Motor Vehicle Program. I was lucky to be a part of the training program. Then many books came, and then I got an opportunity to test my ideas. This is a company by name Innovation Stores, where I worked along with my colleague and also my supervisor, Murali Krishna Ramagiri. And in 6 months' time, we changed the complete factory, how it works. We implemented lean concepts. There I got a first-hand experience of implementing the lean. And our inventory turns, for example, this is one of the blue lines. This is the main building. Our inventory turns went up from 7 to 24, and our COP, quality of cost of food quality, came down to under 6%. And we eliminated second shift, we eliminated the overtime, we eliminated the defect rate, we brought down the defect rate. And so many things we achieved. Then I was thrilled at that time to see the ideas that I have learned practically taking shape in a company. And then zero, the mathematical zero is the concept of, the concept was the gift from India to the world. The concept of zero was not there. The credit goes to Dhanbad and Bhaskara too for defining the mathematical properties of zero. Without zero, there would not have been calculus. Without calculus, the entire technological progress would be impossible. that mysterious 0 by 0, infinitesimal, is the root of the calculus. Calculus is the foundation of all technological progress. And this 0, Indians invented and gave it to the world as a gift through Europe, Italy, and so on. But 0 has applied to operations, was pioneered by Japanese. 0 setup time. That means if there is a machine, the changeover time should be 0 from one product to another product. There should be 0 defects. There should be no defects. Right first time, every time. There should be 0 maintenance breakdowns. Machines breakdown. So how do you achieve 0 breakdown? So they applied this 0 concept to the operations, especially started with manufacturing, then got extended backwards and forwards, upstream and downstream. So ultimately, what I have understood is, if you really understand how to apply 0 concept to the operations, then we must be able to eliminate many things. Because in companies, I visited about 250 companies and worked with about 40 companies and headed one company, the manufacturing unit. This should lead to elimination. That is the top here. If you cannot eliminate, you minimize. For example, there is a quality control department. What is the goal of quality control department? If you ask me, to eliminate itself. That is the goal. What is the goal of purchase department? To eliminate itself. You fine-tune the supplier so much that you really don't need so much staff in your purchase department. Marketing department. If you design products so well, the marketing department gets eliminated. So every department, you look at what they are doing, elimination is the goal. Elimination is the true improvement. That is what I understand. Apart from being an engineer, I am mechanical engineer, B.Tech mechanical, M.Tech industrial engineering, PhD in industrial engineering. Apart from being an engineer, my passion is to study nature very deeply. So I have a habit of delivering lectures, free lectures to my friends at Hyderabad City, and so far I have delivered about 28 lectures for different topics like honeybees, ants, rain, nose and smell, eye and vision, skin and touch. So many beautiful topics I select, prepare very well, and deliver 4 hours lecture or 8 hours lecture. So this is my hobby. Because of this deep study, I started comparing how we make things and how nature makes things. Okay? So if you want to make something, you need material. For example, you want to create a cell phone or a camera. You need material, different types of materials. You need machines to change the geometry of the machine, geometry of the raw material, or the metallurgical or physical or chemical characteristics of the materials. So that to accomplish this, you need machines, and then you need energy to run these machines. Various forms of energy. Then you need information. At various stages, starting from the blueprint of the product to the process parameters of various machines, and then the quality control, the standards, everything you need to, all this information, then only you can make something. So that is the manufacturing. And how we do things usually in our factories, usually it is with a lot of noise, a lot of pollution, a lot of energy, a lot of vibration, a lot of pressures, high temperatures, and in some cases you have to use caustic chemicals. I just want to show 2 small video clips. worry. This is a Amada sheet metal handling machine, punching machine. Next slide, please. Next slide. Okay, leave it there. So, if you observe nature also creates variety of things, billions of varieties, or even billions. Today, it has many parts. Each part has a function which you can describe by a verb and a noun. Now, egg is the link between one generation to next generation, and it is the largest cell in nature. For example, Austin chest is the largest cell that we can see, single cell. Now, in order to make this, it is not possible by us, by any means. For example, we want to produce even an approximate shape of egg and the injection molding process, and egg has about 7,000 to 17,000 pores, so that during the incubation, the contents will get transformed into the chick, small chick. So the gases must go in and out. So it has small pores. So you cannot imagine the egg being produced by injection molding process 17,000 pores. So it is a very complicated process. But nature makes, this is the oviduct of the chicken, and these are follicles, and then the fertilization takes place here, which will take about 15 to 30 minutes, and then the albumen, that is egg white, is, because it has many layers, so break and egg and see it is uniform, that is not good. Egg white has many layers, egg yellow also has many layers. That will take about 2 to 3 hours. And this is coated with 2 membranes, covered with 2 membranes, which will take 2 hours. Then the shell with 7,000 to 17,000 pores are created here, which will take about 18 to 20 hours. So finally the egg comes out, 1 egg every 24 hours. Now the total lead time for manufacturing, let's call this manufacturing for the moment, for the purpose of our discussion. And the lead time is 24 hours, and the total factory length is about 70 centimeters. Now imagine yourself becoming a very small nano type of person, and with a torchlight, you enter inside and observe this factory. What you will see is absolute silence. And this factory is completely dark, what we call lights out factory. And there is health, there are no machines, there are no tools, there are no inspectors, there are no supervisors, there are no expeditors, there are no quality control experts, there is no IT department. Everything happens perfectly by a mysterious nanotechnology type of thing inside the body. So, do you call this truly lean? Is there a quality control department? Is there a maintenance department? Are there machines? Are there tools? Are there workers? There is nobody. If you go back and recall what I said before, eliminate. Elimination of something is true improvement. Here, everything is eliminated. Therefore, I call this factory truly lean. That is what I observe in nature. And take a honeybee. Honeybee is a marvelous miniature flying machine. Independently, it can navigate, it can forage, it can manufacture honey. No, independently it lives in the world. Imagine a robot independently living in this world. Such robots have not been created so far. Now, to create a honeybee, nature uses one cell of honey, 1 cell of pollen, 1 cell of water. You would have seen the honey hive. So it takes only 3 cells of water, pollen and honey to manufacture 1 honey. The cost of honey bee is only 2 cents or 1 rupee. You can calculate the cost. But we are nowhere in manufacturing such a miniature aircraft or a drone at the cost of either 1 rupee or 2 cents. If you look at your body, your body is composed of 98%, 98.5% of your body is composed of oxygen, carbon, hydrogen, nitrogen, calcium and phosphorus. I calculated the material cost of the body, and the material cost is only 400 rupees. Your body is worth only 400 rupees. And then, if you look at your eye is a marvelous digital camera, movie camera mounted on an automatic tripod. So when you are driving, the eyes process about, they are fused to the brain. They process about 20 GB per second. That is the amount of information processing it is capable of. But the cost of the eye, if you compare the eye with a digital camera cannot be directly compared. The eye doesn't work like a digital camera, but there are a lot of similarities. There are many dissimilarities. So eye is manufactured when you are in mother's womb. Your eye is manufactured using 1 glass of water, little salt and egg white of one egg white. And the cost, the megapixel, approximate estimation, there are many estimations, many variations, but one of the estimations based on the resolution is that your 2 eyes are equal to 576 megapixels. But the cost of the eye is only 10 rupees. And the eye usually lasts for 70 years. No, it doesn't get technologically obsolete. And if you consider the brain, your brain is about 1.5 kg. Your brain is a no supercomputer can come near the brain. I hope all of you know that. So the brain, which is 1.5 kg, 80% of it is water, 12% fat, 8% protein, and the cost of the brain is only 40 rupees or 3 quarters American dollars. And the memory capacity, storage capacity of the brain is about 1 million GB. You can compare this with the latest, the microprocessor or internal memory of the latest laptop or desktop. And then processing speed, latest Intel processors have come about 4 GHz, that is the latest chip processing speed. But the brain is much more faster. Again, it cannot be compared directly with a computer because it's so difficult to estimate these things. But one estimate showed that the count all the sensors in your body, your hand has 10,000 sensors, your nose has 10 million sensors. So like that, and your skin has billions of sensors all over it. And internally, inside the body, there are many millions of sensors. So you count the number of sensors and the signal rates and then calculate what is the amount of information that is being sent to the central nervous system. And you will come out with the astounding number. But if our greatest process is at the height of 1 meter, nature is at 4,000 kilometers. That is the gap between. But this computer, that is the human brain, also 40 degrees. So, and the brain has to write programs. If you want to get up and go to the bathroom, you have to write a program. And if you want to grab a cup of coffee, it has to write, because we have 650 muscles. And each muscles have to be moved in accordance with what velocities, acceleration, and then trying to break. So all these things are controlled by program. Maybe it is digital plus analog, both. And then the average person's brain writes about 550,000 programs per day. And there is no quality testing department is not there. You write the program, program is perfect, program is executed. So that is how nature works. And then out of my interest, I attended workshops on nanotechnology. In 2009, I went to Boston to attend a 3-day workshop. And then I usually visit nanotechnology labs. This is my recent visit to Glasgow University, James Watt Nanofabrication Center. So you see the complex, this is the clean room. You see how much effort has to be taken in order to prevent dust or vibration to get into these rooms, because they are handling atoms. First time in the history of life, with the advent of many tools such as scanning from the microscope, atomic force microscope, and so on, we are able to see atoms and manipulate atoms and create devices that can be something similar to what nature has been doing for millions of years. And when you come to recycling, best products must be recycled in a natural way. If you throw a digital camera in nature, it will take millions of years to become part of nature. The logic is this: we are borrowing material from nature. We cannot create any material by ourselves. We borrow materials from nature, or we giving it back to nature so that nature can use it to do something else. That is missing. This is a beautiful poem. Please read it on the web. We wrote a time. One horse shape. About 130 years ago, he was a Harvard medical professor at Harvard University. He wrote a beautiful poem on a mythical being who is higher than human beings. Designs one horse buggy. So its life is 100 years. Exactly after 100 years, it will decompose. All parts will decompose into its constituent forms. If you take human body, each organ may fail at a different time. For example, if all the organs, heart, brain, nose, all the organs, liver, pancreas, everything, kidneys, if all organs fail at the same time, you don't need doctors. The medical profession, what is the goal of medical profession? To eliminate itself. That is the goal. When they find all the cures, they are going to medical profession. So again, you have to go back and leave that zero and eliminate. Apply this logic to every field. So please read that, and nature has been doing that for millions of years. Take a read, compare with solar cell. What solar cell can do is convert sunlight into electricity at the efficiency of about 25% to 40%. But leaf is much more efficient, and also when it dies, it becomes part of the nutrient that is required for the tree, so that new leaves can be. But if you throw a solar cell of 25 years of usage, it will not be useful to make another solar cell. It only will pollute the earth. And again, you can see many mysteries in nature. For example, you would have seen how a caterpillar becomes a butterfly. Caterpillar is a mud crawler. I mean, it needs a substrate to navigate, move. Maybe it is a branch of a tree, or a twig, or a leaf. But this mud crawler must become a flying machine. That happens, the transformation happens in the chrysalis or the pupa, which we call metamorphosis. So that is something like this. You take, I will give you an old car to you. You take this car, go into a factory which is completely dark, and I will not give you one molecule of extra material. I will not give you 1 kilocalorie of extra energy. But you are allowed to exchange gases through this wall of the dark factory, and I want a helicopter out. That is the complexity that nature has accomplished silently, and that is the type of transformations that happen all around us, and we can watch. And this is the battery, lead acid battery, which we have in our cars, and this is the electric heat. Lead acid battery is made of the very caustic materials, polluting materials like lead, lead alloys, sulfuric acid, glass, and plastic, and copper. But this is the electric eel, which can give a shock of 500 volts to 800 volts and recharge in fraction of seconds. again to give another show. This is the electric eel that used in the muddy waters of South Amazon, and this is when this dies, it becomes part of nature. When you throw a battery, it pollutes the earth. And then when you die, just imagine what will happen to your 576 megapixel camera, the motor pump set here, and also the hot electromagnetic device that can work non-stop for several years, and the supercomputer, the brain, everything becomes part of nature in a couple of weeks. Nothing left is left behind except some big bones and other things. So nature has excelled in product design, in manufacturing, in recycling, reuse, remanufacturing, and the nature can only be the master of lean, and we have to learn much from nature in order to implement lean in future years in systems.